So this is just going to be a quick video where we look at the proof that the square root of 2 is irrational, which is one of the formal proofs you can be asked in the Leaving Cert exam. So anyway, first thing we need to know is what an irrational number is. So an irrational number is a number you can't write as a fraction, or kind of a more formal definition you can't write in the form a over b, where a and b are both integers, alright? So irrational numbers are non-repeating and non-terminating, or else never-ending. Normally have decimals, they just keep going on and on and on and on. So examples of irrational numbers are most surds, so because of the square root of things, so the square root of 2, square root of 3, etc. Pi is an irrational number, and then e as well. So e is that magic number we come across in logs and calculus a little bit. So they're all irrational numbers, and they are still real numbers, so they're not complex numbers or anything like that. Yeah, and that's pretty much everything we need to know about irrational numbers for this for the course and for this proof anyway. So I'll go on a little bit. So the proof is called a proof by contradiction. So proof by contradiction. So the reason it's called a proof by contradiction is that we assume something is true, and then we do a little bit of maths, and the maths will contradict itself, and that means what we assumed is true at the start can't be true. So hopefully you'll see what I mean when I start it. So there's a few different steps to it. The first step, like I said, so I'll just go in purple. So I'm going to say step 1 for this proof is we assume that the square root of 2 is rational. Okay, so we assume it's rational, and this means, like I said, irrational numbers, you can't write them as a fraction like this. So that means a rational number, you will be able to write them as a fraction like that. So that means I'm going to write the square root of 2 is equal to a over b. And it's also important to say that a over b can't be simplified. Okay, so can't be simplified. Or else another way of saying that it doesn't have any common factors. Okay, doesn't have common factors, and the reason that is, if it has a common factor, then you'd be able to simplify it. So there's two ways of saying it doesn't have a common factor, and you'll see why this is important later on. So we have to assume this is part of the first step. Okay, so the next step we're going to do is we're going to square both sides. So I'll go green for step 2. So we're going to say step 2, square both sides. So square both sides. I'm going to continue this in red. So if we square both sides of this little equation here, we're going to get 2 is equal to a squared over b squared. So the square root of 2 squared will give us 2, and then a squared over b, or a over b squared will give us a squared over b squared. So that means, I'll rearrange it a little bit, that a squared is going to be equal to 2b squared, and this implies that a is even. Okay, so you can think about that for a little bit, that if b is any number and you multiply it by 2, it's going to be even, and that means that a is even as well. But it's probably easier just to learn this step off, just that a is even. So take it for granted that if a squared is equal to 2 multiplied by b squared, that a has to be even. So now there's a third step. We're going to keep going. So right, step 3, and this is, we'll say let a be equal to 2k. So the reason we're doing that is because if a is even, then you can write it as 2 multiplied by k, where k is some other random number, because 2 multiplied by anything will give you an even number, right? So now what we're going to do is we're going to square both sides here. So it's going to be a squared is going to be equal to 2k squared. So that's going to give us that a squared is going to be equal to 4k squared. And also remember that a squared is equal to 2b squared. So just draw a little box around that here. So we're going to bring that down. So that means if a squared is equal to 4k squared, then 2b squared also has to be equal to 4k squared. 4k squared. So now I'm going to divide both sides by 2, and we're going to be left with b squared is equal to 2k squared. Okay? And so you know what that means again? The same reason as this up here, that b is going to be even. So b is even. But now this is where we get to the end of our proof. This contradicts our first step, so I'll say that down here. Oh, okay, I'm actually just going to have to go across through that. So I'll say step 4. Step 4. So this contradicts our assumption. This contradicts our assumption, and our assumption was that you couldn't simplify a over b. So a over b, I'll just say not simplify. But if we see, like we have in those two results here, that a is even and b is even, if you write two even numbers on top of each other, no matter what they are, they're going to simplify. So this contradicts our assumption, yeah, like I said. So that means square root of 2, so it can't be rational, and then just our final bit will say, therefore the square root of 2 is irrational. I'll just put a box around that. So that's the end of the proof. If you don't completely understand it, it doesn't really matter too much, because as bad as it is, you can just learn this proof off and then puke it back up. We'd recommend trying to understand it as best you can. It just helps for remembering things, and it's also just good if you understand things instead of just memorize them. So again, that you have to know what an irrational number is. Then you have to know this is a proof by contradiction. You have to write all of these things down. So step 1, assume square root of 2 is rational. You have to write this step down, and then adding that little side note in does help. So now we're going to say square both sides. You have to say a squared is equal to 2b squared. You have to say that a is even. Then step 3, you have to write all of this here in step 3. So you have to finish with b is even, and then you have to go across, and you're going to say step 4, this contradicts our assumption, and then you won't just write a over b not simplify, but you'd say this contradicts our assumption that a over b can't be simplified, because if a and b are both even, then they could be simplified, so that contradicts our assumption. Therefore the square root of 2 can't be rational, therefore the square root of 2 is irrational. And that's the end of that proof anyway, so I hope you guys enjoyed it. Again, that's going to be on, or it could be on your Leaving Cert. It's a formal proof, so make sure to learn that off, because it's easy marks if it does come up. Yeah, that's it for now. In the next video, we're going to look at the theorems, so the geometry theorems you have to prove. If you like this video, don't forget to like and subscribe, and tell your friends about it as well. So we'll see you in the next video about geometry theorems.